Aspetta che parto anche con la condivisione. Ok. Mi confermi che arriva
Sì, sì, è condivisa
subito?
e ti sentiamo. Perfetto.
Perfetto. Ok, buongiorno a tutti. Come prima cosa ci presentiamo, per chi non ci conosce. Io sono Alessandro Andretto, faccio parte dell'area di sistemi informativi e sono il capo ufficio dell'ufficio sistemi integrati per la ricerca. Collegati con noi ci sono appunto Elena, che avete già sentito, che è la nostra referente per l'open access e l'open science, e i colleghi Paolo Brambilla, che si occupa di data steward per Bicocca, e il collega Luigi Zegliani, che è del team che si occupa di BOA e di Iris e di BOA. Ecco. Abbiamo sfruttato questi 10 minuti prima della presentazione appunto del fornitore per darvi il contesto in quale noi andiamo a presentare questa attivazione di un nuovo servizio. Infatti appunto sarà una brevissima presentazione per cercare di allineare un po' tutti i partecipanti, anche gli utenti, sul contesto da dove siamo partiti e come verrà utilizzato questo strumento all'interno dei servizi che offre in questo caso l'area di sistemi informativi. Stiamo parlando sicuramente di un'attivazione di un nuovo servizio che è tra le prime adozioni di un sistema di ELN, Electronic Lab Notebook. Perciò è un software che andrà a sostituire, o comunque a sostituire, i quaderni di laboratorio, oppure andrà a supporto, e si parla già di un software che andrà a semplificare. L'obiettivo è quello di andare a semplificare la gestione dei dati della ricerca e garantire una serie di conformità relative a GDPR, privacy e tutti i processi relativi alla gestione dei dati della ricerca, e con un focus orientato alla possibilità di collaborare tra membri di un laboratorio, un gruppo di ricerca, e un altro obiettivo è quello di andare a cercare di integrare questo strumento all'interno di un flusso più ampio di strumenti che mette a disposizione l'Ateneo. L'idea che noi abbiamo appunto è che oggi avremo il primo assaggio delle funzionalità dello strumento per tutti gli utenti, è quello di andare a creare e di adottare questo strumento che si chiama RSPACE, creato da un'azienda inglese, e sarà quello di andare a creare un hub al centro del flusso ideale della ricerca, perciò partendo dai dati, la gestione dei dati come il data management plan, oppure i dati grezzi che possono essere salvati, storati in vari servizi. RSPACE si mette in mezzo per cercare di essere il collettore di tutte queste informazioni e consentirvi di gestire in maniera più fluida tutte le informazioni che vi possono supportare nell'attività di ricerca. Inoltre, RSPACE è il punto anche di partenza su quale sarà possibile andare a ripubblicare i dati, ad esempio sull'archivio istituzionale. Noi abbiamo il nostro board Bicocca Open Archive Research Data, che è il nostro repository dove è possibile andare a depositare i dati finali della ricerca, e perciò andare così a completare un po' tutto il flusso teorico della gestione dei dati della ricerca, dalla preparation dell'attività di ricerca e poi la parte di archiviazione e storage dei dati, ecco, e la possibilità di riutilizzo. E questo progetto è partito già un anno fa su esigenza del Dipartimento di Biotecnologie, che aveva manifestato l'esigenza di utilizzare uno strumento strutturato per andare per gestire appunto il quaderno di laboratorio. Ad oggi in Ateneo non vi erano soluzioni standardizzate o comunque offerte dall'area sistemi informativi, perciò si è cercato di mettere a sistema l'esigenza di un dipartimento e cercarla di mettere a disposizione di tutti i dipartimenti che ne possono far uso di questo strumento. Il sistema dopo una ricerca di mercato abbiamo effettuato già l'anno scorso un po' 2 o 3 mesi di trial con alcuni utenti, magari anche alcuni di voi sono stati coinvolti, e alla fine di questo trial abbiamo fatto un resoconto e l'utilizzo di questo strumento era stato indicato con una serie di vantaggi, di utilizzi importanti, e perciò si è orientati sull'acquisto di un numero di circa 200 licenze per l'Ateneo. In questo contesto abbiamo state distribuite le licenze per i vari dipartimenti che ne hanno espresso le loro esigenze, e andiamo un po' a definire anche l'organizzazione delle informazioni dei servizi che mi mettono a disposizione, in questo caso i sistemi informativi. In prima battuta vi è sicuramente il punto di contatto con il team che se ne occupa, e il nostro punto di riferimento è una casella di struttura openscience@unimib.it, che in pratica potete contattarci direttamente per qualsiasi esigenza. Avete a disposizione, abbiamo creato un Google Groups sugli utenti che sono stati abilitati alla piattaforma in base agli Excel che avevamo condiviso. Dal punto di vista invece della documentazione abbiamo 2 punti di riferimento che saranno il sito Open Science UniMiB, il quale nei prossimi giorni andremo a creare delle pagine dedicate e anche tutta la documentazione a supporto dell'utilizzo del sistema, compresi anche i video, le videoregistrazioni che faremo delle sessioni con il fornitore, e oltre al sito del fornitore che ci mette a disposizione una piattaforma di documentazione molto ricca, che è quella che vedete in questo momento in video, documentation.rspace.com. I prossimi step che abbiamo in mente è la profilazione delle utenze che ci sono arrivate nei giorni scorsi. Ad oggi non abbiamo ancora profilato tutti gli utenti che ci sono arrivati, ma lo faremo a stretto giro anche con l'aiuto del fornitore, e avremo necessità di individuare dei membri, dei referenti per dipartimento, così che facciano da punto di riferimento locale e verticale sulle esigenze, ad esempio del dipartimento, i quali ci aiuteranno un po' nella gestione e a capire i punti di forza e i punti di debolezza dello strumento, eventuali criticità oppure miglioramenti che possono essere utilizzati, possono essere implementati. Scusate. E ultimo punto, è un punto, come dicevo prima, noi abbiamo acquistato un pacchetto di circa 250 licenze. Ad oggi ne sono state prese una gran parte, sono state distribuite tra gli utenti che ci avete indicato nei file che sono circolati nelle scorse settimane, e in caso abbiamo ancora degli slot liberi in caso di necessità specifiche, abbiamo intenzione di utilizzare questo pacchetto di licenze magari per distribuirle per eventuali esigenze specifiche e verticali di ciascun dipartimento. Ecco. Un po' così è un po' la presentazione molto rapida dello strumento che andremo a vedere oggi. Quello che mi premeva un po' anche andare a indicare che appunto lo strumento che abbiamo individuato è uno strumento che avremo in adozione per circa 9 mesi, perché abbiamo già integrato col single sign-on una serie, abbiamo avuto già un periodo di adozione, di configurazione, e in questo periodo sarà un periodo di forte sperimentazione, e vi chiediamo anche una mano per indicarci le criticità o indicarci punti di forza e di debolezza, per poi andare a fare un'analisi ancora più dettagliata sia sul numero di utenze che ne possono essere utili, o ridimensionamento delle licenze perché magari ci sono dei casi d'uso in cui non lo trovate adatto, e perciò vi chiediamo una collaborazione e anche un'interazione ad esempio con la casella di struttura Open Science che è su UniMiB.it, per affrontare tutte le criticità che vengono fuori con l'utilizzo di questo strumento. Ecco. Non so se ci sono domande, mi sono andato forse un pelo lungo come 4 minuti ancora, 5 minuti prima che arrivi il... Vedo delle domande, non vedo che c'è qualcuno con la mano alzata, forse mi sbaglio. E se è rapida la facciamo subito, se no altrimenti la... Che
Sì,
dici?
io vedo Fabrizio Piazza, ognuno di voi è
Sì, con la
libero
mano
di riattivare l'audio e anche il video,
Ok,
quindi
Buongiorno.
sono... Ecco,
Buongiorno.
prego.
buongiorno.
Volevo fare una domanda molto rapida, grazie per la presentazione. La prima era, avete detto che ok, è conforme GDPR. Io lavorando a medicina mi trovo spesso con dati molto sensibili, pazienti e anche contratti di riservatezza.
Sì.
Posso utilizzare questo programma anche per storare grosse mole di dati clinici associati a pazienti, dati sensibili? E la seconda domanda strettamente associata è assicurato la totale, diciamo, esclusività nell'accesso di questi dati unicamente al PI e agli utilizzatori del gruppo abilitati a farlo? O c'è anche un qualsiasi forma di possibilità di accesso da parte di, chiamiamolo genericamente, l'istituto?
Ok, allora sui dati sensibili provo a rispondere è una domanda piuttosto complessa, perciò magari cerco di essere super sintetico, ma magari approfondiamo, cerco di darle tutti gli elementi. Allora, il sistema, parto dalla fine, che è la parte più semplice. Il sistema è altamente gerarchico e consente di gestire le informazioni in maniera molto verticale. È installato su un'installazione su un cloud pubblico di Amazon in Italia e è accessibile solo a noi, ok? Perciò un'installazione ad hoc per noi. Sui dati sensibili, cartelle dei pazienti, invece faccio un passo indietro, perché i dati, questa tipologia di dati comunque deve essere, prima di essere gestita all'interno del sistema, bisogna fare un passaggio col DPO e con i colleghi perché non è un sistema come può essere RedCap Cloud, che è per i trials clinici, perciò già pensato per la gestione dei dati personali e sì, ultrasensibili come possono essere i medici. Perciò magari l'idea potenziale potrebbe essere che lo storage, in verità, come mostravo nella diapositiva di prima, è una parte iniziale dove praticamente dove li metterete, adesso non so voi dove li salvate sinceramente queste informazioni, però possono essere linkate attraverso sistemi di interoperabilità con RSPACE, perciò avete dei collegamenti diretti al vostro database che utilizzate.
Ok.
C'è qualche...
E una ulteriore chiarificazione in merito alla prima risposta. Il sistema
Sì?
gerarchico verticale, all'apice della gerarchia c'è qualcun altro oltre al PI? Cioè, sistemi informativi, voi potete accedere a questi dati o solo e unicamente il PI?
E l'amministratore del sistema può accedere alle informazioni presenti all'interno l'amministratore del sistema, che sono alla fine 3 persone dei sistemi informativi, possono accedere alla visione dello spazio dei dati. Come dicevo prima, dipende dopo dove sono storati i dati. Se voi caricate tutti i dati lì, non è il sistema di storage per dati sensibili, è un punto intermedio tra lo storage vero e proprio e dove andate a indicare i protocolli e tutte le azioni che andate a fare sui dati all'interno del
I raw data potenzialmente sensibili, coperti magari da riservatezza, non chiamiamola sensibilità di pazienti, raw data, quindi completamente codificati, anonimizzati, ma risultati con un contratto di riservatezza con un'azienda. C'è
Sì,
qualcun altro che può avere accesso? Sì, mi pare di
sì,
capire.
il sistema, tuttavia, in questo momento qui ci sono solo gli amministratori di sistema e dopo in base all'organizzazione gerarchica che mettete in campo.
Ok.
Il sistema è strutturato da una gerarchia amministratore di sistema, PI e laboratorio, semplificandola molto, perciò questo è un po' l'organigramma in cui viene. Sono tutti compartimenti stagni tranne per l'amministratore di sistema praticamente. Okay. In
Grazie
questo
mille.
caso sono attivi 4 amministratori di sistema. Però se su questa parte avete bisogno di un ulteriore passaggio, lo facciamo anche con i colleghi che si occupano di privacy, DPO e tutto quanto, così andiamo a chiudere il cerchio su queste eventuali necessità. E il sistema consente di essere è conforme con gli standard della 21 CRF Part 11, che è quella lì del sistema sanitario americano, perciò avrebbe tutte le caratteristiche per gestire anche un certo tipo di dato, però su questo è meglio approfondire e fare un focus dedicato, perché in questo caso, avendo preso uno strumento generalista, il nostro obiettivo era quello di dotare tutti i dipartimenti di uno strumento funzionale, ricco di funzionalità, e poi sulle verticolarità magari ci addentriamo un po' di più.
Grazie ancora.
Niente.
Se ci sono velocemente altre domande brevissime, altrimenti io vedo Robert Day già collegato, quindi se volete possiamo cominciare la formazione e poi magari lasciare le domande alla fine o anche contattandoci in separata sede, ecco.
Ok, penso
Alessandro,
possiamo...
procediamo, sì.
Okay.
Allora, innanzitutto grazie Alessandro per l'introduzione, così abbiamo dato un po' una mappa, una panoramica sull'ELN e su quelle che sono state le ragioni della nostra scelta iniziale. Io direi appunto di procedere. Rob è già collegato. Robert Day è il nostro punto di riferimento in RSPACE, ci ha seguiti sin dall'anno scorso, quindi sin dalle prime fasi di indagine di mercato, e quindi ci siamo confrontati spesso con lui, che è stato veramente preziosissimo nel guidarci, nel darci tutte le informazioni sia dal punto di vista dei contenuti che delle caratteristiche tecniche di RSPACE. Rob, can you hear me?
I can hear you just fine, Elena.
Yeah, okay. Good morning, Rob. Rob is located in USA. Rob è in America, quindi è prima mattina. Thank you, Rob, for your usual punctuality. We have just provided our Bikoka users with an overview on the ELN, the reasons behind our choice, and a few practical instructions. So please be so kind to introduce yourself, and whenever you want, we are ready for our training.
Right, so let me go ahead and I'm going to share my screen right away just to make sure that works before we do anything else.
Yep.
Okay, can you see my browser moving left to right now?
Yes.
Okay, good. So that's one hurdle across. I'm also going to rearrange some WebEx windows. There's floating windows all over the place here that make it a little tricky for me to work here. Okay, so thank you so much for joining me today, everybody. I'm Rob Day, and I'm head of product and head of North American operations here at ResearchSpace. My background is that I have a degree in molecular biology from King's College in London, and I came to the Ohio State University in the US to do my graduate work. And to my considerable surprise, I ended up settling here, and now I live here in Columbus, Ohio. I've been involved and interested in ELN for a very long time. I started getting interested in digital recording of data when I was in graduate school. And I've been involved with a number of different ELN products and bioinformatics products over the years before finally ending up working with ResearchSpace. I really like ResearchSpace because my heart very much still is in academia, even though I haven't been in a lab in a long time. But as a former bench worker, I sort of am very familiar with everyday scientific workflows and the value of the data to the users. And I see my role often at ResearchSpace as acting as the advocate for the frontline scientists who are using our product to help make sure that the product is actually useful and ends up helping them save time and be more productive and do better science rather than simply going through the motions of using an ELN for the sake of just using it. So I do understand exactly what you guys are doing in the lab, and I'm very committed to this project because I think it's important. I think science can benefit from it enormously. I think it's very clear that in modern scientific research, most projects have become so complex and so filled with data and so collaborative that it's simply impossible to do good science any other way, and that the era of the paper and pencil recording mechanism in the lab has now sort of officially ended. And it's time for everybody really to move to a digital platform where they can be more effective and collaborative. I will also mention that briefly, you haven't already seen this image before, RSPACE is more than just a simple notebook. So RSPACE is not really merely a replacement for something like SharePoint or Dropbox or OneDrive, or using a file server in your lab to store all of your data in a place where everyone can access it. It's more than that. It's also designed to act as kind of a hub and a data processing pipeline to allow you to pull in and refer to data in many different places, and ultimately be able to show your downstream data where that data is currently located, bundle up that data, and eventually send it out to long-term repositories. And it's also increasingly designed to work with modern digital identifiers, which can help your downstream audience more easily find the work, understand its meaning, and also locate it using things like common metadata schemas. In other words, things like widely used keywords and descriptions that reflect the way that researchers in your particular research sector identify, label, and categorize your work. So it's a lot more than simply a note-taking mechanism. That's really a minor part of what it does. When you log into your own server, you should be making sure that you see something like this. So this is just basically a screen capture of your server. There are two critical things you need to check for. Make sure that you see the UniMiB University logo that tells you that you're in the right place, and make sure that the URL is correct and matches what you see here. If you found your way to any other kind of server, you are probably in the wrong place, and you'll see a different URL and perhaps a different image here. RSPACE servers are unique to each large customer. So each institution or organization, or in some cases even some small labs, have their own RSPACE server that's completely private to them. And that server may be located on a machine within their own network, or it may be located in an approved Amazon private instance. But at no time is your data mingled or shared with the data of other people. It's all only on your specific server, created and set up and optimized just for you. So it is important that you make sure that you're connecting to the right server, and that you somehow haven't acquired a link or a pathway to get access to somebody else's server, or perhaps one of our public or demonstration servers that we keep active. That's not where you want to be. You want to be on your production server with this URL and with this logo associated with it. You can at any time go to our help page. We strongly recommend that you visit this frequently. It's all completely searchable. So if there's something that you want to learn about here, you can simply type in something and it'll give you good responses right away. You can then follow these links to learn more about the thing that interests you, or you can use this breadcrumb trail here to search for a hierarchical list of topics that might be interesting to you. And you can click on anything here if you need to learn more about anything that we see today. Here's the URL for this site. It's researchspace.helpdocs.io, and there are several ways you can reach this that I'll show you in just a moment. Here is a demonstration server that I've already logged into. So this is a server that I often use in my demonstrations. You can see the URL is different to the URL of the server that you will use, and you can see we have a different image here. I'm logged into this server using a demonstration user that's already generated quite a lot of content. But before I switch to that user, I'm also going to show you what you'll see the very first time when you log into RSPACE. So this is that demonstration server again, and I'm going to log into this server as a user I just created a moment ago. So let's log into this server as new user 1, and this is what you see the very first time when you log in. You may get a pop-up welcoming you. You may see pop-ups that will show you notifications of things that have already happened before you've even logged in for the first time. For example, invitations to join certain lab groups or other things that have happened on your server. In this case, though, I just see the basic interface and I don't really see any initial data, but I do see these 3 system-created folders. You'll always see these when you log in as a new user. As a brand new user in RSPACE, I would recommend that the very first thing you do to get started is go to the Create menu and then choose a way to make a new item from this list here. Now, there are several ways that you can start working inside the ELN, but probably the easiest is to choose the basic document option. And that will make a document that looks a lot like a blank sheet of paper, as we'll see in a moment. I could also make new documents based on these things called forms or templates. By default, you will have access to a small number of forms, but you can make your own forms at any time using the RSPACE form building tool that you can access down here. Forms and templates represent multi-step different sorts of workflows and experiments that you often do and that you'd like to do the same way each time you complete them. You can create these and distribute them around your lab. You can use these to make sure that everybody in the lab is performing different procedures in the same way. You can also make brand new documents by bringing in certain sorts of files from the outside world and immediately converting them into RSPACE basic documents. So for example, you can immediately import MS Word files and turn those into RSPACE documents. You can immediately import Evernote packages and turn those into RSPACE documents. And you can also import protocols that you've located from protocols.io if you want to. Let's start by doing something very simple. I'll just click on Basic Document, and that will make a new, empty, blank RSPACE document. The RSPACE document is sort of the unit of knowledge within RSPACE, and it usually represents something like an experiment or a workflow or a data collection event. An RSPACE document may be quite complicated and filled with many different fields arranged in a sequence. Some of those fields may be optional, some may be required. And those fields will allow you to enter different types of data in a specific sequence. Right now, though, we're looking at a very simple thing called an RSPACE basic document that's made up of the RSPACE text editor and so far just a blank space. You can think of this as being like an empty sheet of paper or like an empty MS Word or empty text file. And you can use this to work in a very free-form way if you want to generate whatever you like in this space. So I could immediately start typing and saying, today I will, and start making some text. Or if I wanted to, I could immediately start dragging in various different files into the space if I wanted to. I could go to my local computer, find an image that I like, select an image, and just drag and drop it onto the page like that. I can then take that image and I could change its formatting on the page, or I could change its size. Or if I wanted to, I could immediately start annotating it and adding text or other indications on top of this image that won't damage the image, but will allow me to add some meaning to this so that I can allow my downstream audience to understand better what this image does or means. Any file that you drag and drop into a basic document or anywhere else in RSPACE will also automatically appear in this other area here called the gallery. So the gallery is the second major area of functionality of RSPACE. It acts like the file store of the system. If you want, it's a replacement for something like Dropbox or OneDrive or your own local computer where you would normally store files. If you don't use RSPACE for anything else, we would strongly always recommend you keep all of your important research data files stored in RSPACE where they are safe and secure, where they are backed up by a professional IT team and processed all the time, and where they are fully linked to what we call 21 CFR 11, which is a rule set that allows your downstream audience to understand exactly when this data was gathered and who gathered it, and to guarantee that this is a true and accurate work of the files and the work that you collected at the time. So the gallery is one of several different functional areas you can see here. The gallery is where you basically store files. You can organize these hierarchically by file type and make folders to store them in. And the workspace is where you're going to create work that that describes what you're doing in the lab. So if I click on this document again that we started earlier, you can see here again, we've got a little bit of text and an image in this case. So working on a basic document is probably the first thing you'll want to do. It works a lot like any other text editor. There are many different sorts of editing tools that you can access here. You've all worked with text editors before, so I'm not going to spend an enormous amount of time going through this. I would recommend you simply click through these different icons, practice using what they do, and if you want to, at any time, you can click the Help button down here. You could go ahead and say text in the Help area, click on Text Editor, and then click here to go into full page mode to see more information about how the text editor works. This page will walk you through all of the different functions inside the text editor and help you understand exactly how our specific text editor works in terms of editing, creating tables, and other kinds of rich content. These are really all the sorts of same things that you might do in almost any other text editor like MS Word or OneNote or whatever text editor you like to work with generally. I will show you also that if you want to, there are a couple of really important features here. If I go to the File menu, I can jump to Shortcuts, and this will allow me to do things like associate different symbols with different keystrokes. This can be especially useful if, for example, you often work with a particular symbol in your line of work. For example, if you're a microscopist, you might often work perhaps with the angstrom symbol, and you could assign that to a particular keystroke that you find useful. And I will also point out the fact that from the File menu, you can also configure your toolbar you can drag different icons on or off of your text editor toolbar, much like the way you can customize your MS Word tool ribbon in order to have just the things on here that you use most frequently. Okay, so I'm going to sign out as this brand new user who doesn't really have any data yet. I'll close this browser. And now what I'm going to do is I am going to switch to Chrome, where I'm already logged in as a much more mature user who has an enormous amount of data already pre-created in this account that you can see here. So when I look at the workspace for this user, you can see we have a large collection of different types of RSPACE documents. And I also have here notebooks. And if I increase the number of items per page that I'm looking at, if I go up to 30 items per page, you can see that I also have access to a range of things like folders too as well. So the RSPACE documents, as we said, these represent things like experiments or workflows that you do often. They could all be basic documents, or they could be a mixture of basic and customized documents that you've made earlier. We'll look at the difference between these different sorts of documents in just a moment. Notice that by giving these different document types a custom icon, it makes it very easy for me to quickly recognize different experiment types and different workflows within my workspace. I can organize these documents either hierarchically into folders. So for example, here we have a collection of similar documents all held in a particular folder. To go back up a level in my hierarchy, I can click Home or just click the Workspace tab again to go back up to the top level of my directory. If I look inside a notebook, you'll see here in the notebook, I have a collection of documents arranged in a sequence. Folders and notebooks are really quite similar. A notebook is really just a special type of folder that's designed to tell a story. So in folders, you can hierarchically organize your data any way you want in as many subfolders as you like, just like you do on your own personal computer. In a notebook, your documents will always be arranged in a flat linear list, organized chronologically. Notebooks are specifically designed to tell a story of your activities. If I go back to the home page, I also have the option to click on the notebook itself to see the notebook in a slightly different view. And this will allow me to see a listing of the different pages in that notebook. Within the context of a notebook, we call those entries. I can click on one of these to jump to it directly, or I can use these arrow keys to flip through the pages of my notebook, much like flipping through the pages of a paper notebook if that's what I want to do. So there's a special notebook view mode that I can use for viewing notebooks that helps me understand the story of my research or the story of this particular project. Again, if I want to, I can use this breadcrumb trail at the top to go back up to the top level of my hierarchy anytime. Okay, so now I'm going to look at something a little bit more complex. Let's look at making a document that has more structure to it. I can say create, and from here again, if I want to, I can make new folders or new notebooks. I could make a new basic document, or I could make other types of document that I've made recently. RSPACE will remember different documents that you've used frequently, and we'll show those to you at the top of this list. If you're new to RSPACE, this top area will only contain one thing, the basic document indicator. I could also go to my form area, and here I can see a list of forms that I've built earlier. We'll talk more about building forms in the advanced training session, or you're welcome to look at the documentation to quickly learn how to make forms yourself based on what's in our help area. So there are many types of forms that I've made here previously representing different sorts of workflows that I personally often use in the lab. One of the things that I've done in the past is I do have a bit of a background in histology. So you can see here there is a document called tissue samples, and this is generally used for collecting documentation that's provided by a local hospital that's providing samples for me for use in my research. So if I tell RSPACE I'd like to make a new document based on this form by clicking this item, RSPACE will make a new document. And this type of document is called a structured document. And you can see in this case, it's made up of a list of fields arranged in a sequence. Now, I designed the form on which this document is based. And in fact, if I go to the info here, you can see here now is the unique identifier of the document that I just produced. And here is the unique identifier of the underlying form on which this document is based. I can now start editing this form to add specific sorts of information. So if I work through these different fields here, I can click on each field to go into edit mode. I can say this is going to be liver. I can say the sample ID that came from the hospital is this. The format Here I can choose between these two different options that I decided when I built this form. Let's say this is going to be FFPE. For collection date, I can choose a date from this list. I could equally easily have added a collection time, and I could fill in that. I just didn't happen to do that in this particular form. And then for location, here are a number of options that I specified when I built the form. I could choose one from this list, or I could just start typing something and select something from the list here that RSPACE recommends, and then say save here. This last field here is the familiar RSPACE text editing field. So you can see that this field actually can be one of the field types that you make in your documents. You can have as many of these fields as you like inside a document if you wanted to. You can have multiple RSPACE text editing fields arranged in a sequence for different sorts of purposes. I can show you an example of that in a moment too as well. This particular field is asking for a description and an image. So I could say this is liver showing NASH. And then I could go ahead and I could add an image to this page. Now there are several ways I could do that. I could drag and drop an image from my local computer if I want to. I could just rummage around in my local machine and drag an image on here. Or I could say insert from computer to bring up a file chooser to allow me to pick something from my computer. Oh, by the way, I see that there are some hands being raised. So I'd actually ask you to go ahead and type any questions that you have in the text, and we'll try to address those later towards the end too as well. And in fact, if Elena and the rest of the RSPACE team at UniMiB could keep an eye on those questions and maybe sort of summarize them for me at the end, that would actually be useful to help me answer those questions more efficiently.
Bene. Yes, sure.
So I'll type some text here, and if I want to, let's imagine that I already know that the image I'd like to use today is already in RSPACE because I added it to my gallery earlier. If I want to, I can say insert from gallery. That will give me access to my RSPACE gallery. From here, I can see that there are actually different areas for different file types. There are areas for images, sound files, movie files, basic documents of different types like MS Word files and PDFs. There is an area for chemistry structural files. If you're a chemist, you can store all your chemistry structures in RSPACE. There's an area for miscellaneous scientific file types. You can add any file in any format or any digital object from any source directly to the gallery. We'll talk more about how that works later. There are also some areas for other things here that we'll talk about in just a second. For now, I'm going to go to the images area, and I'm going to say that I would like to look for something that has something to do with NASH. Here I have a whole folder of images. I can go ahead maybe and pick one of these and go ahead and then say insert, and that will add that image onto my page like this. Again, if I want to, I could adjust its size so I could have it look nice on the page like this. If I want to, I can also look at information for this image. I can see here is its unique identifier. Here is its location within the RSPACE gallery. I can also see here the size and the person who added it. I can add a fully searchable caption to this if I want to. And I can also click on Show Link Files to see whether or not this particular image has been used in other RSPACE documents. And sure enough, I can see that it has. It's been used in several other RSPACE documents. And if I wanted to know how it had been used in this context, I could right-click on this and say, open that in a new window. And that will let me see how that image was used in some other RSPACE document that I've used the image in. So this is an example of one of the many traceability features that we build into RSPACE. This particular feature is designed to allow you to use the same file many times in many different contexts without having to constantly upload hundreds of replicates or duplicates of the image. You only need to upload it once to your own personal gallery, and once it's there, it can be used in any experiment or workflow you want, and RSPACE will keep a constant list of how that file has been used and which experiments it's been used in. We actually do the same thing in many other places in RSPACE to help you trace which resources have been used in which experiments and which workflows and which people have had access to them at which time. Okay, so now I'll save this one. And now you can see here we've completed a simple workflow by adding required information in a sequence. I can also at any time here go back and edit these. I could, for example, add another file to this. Let's imagine I'd like to add a pathology report to this section of the document. I can go to my local computer. I can look for pathology reports that I think I have in here somewhere. There we go. Here are some. I could grab this and drag it onto the page like this. This one happens to be an MS Word file. I can save this here. And now if I want to, I can go ahead and see a small thumbnail. I can see a larger thumbnail of that document. I can click View to see this using a technology that RSPACE has, which will display it in high resolution in a new tab. Or if I prefer, I can also go ahead and say, open up this MS Word file in MS Office Online, and that will open up the document using our integration with MS Office. If you don't like using MS Office, your server can be configured to work with an alternative open source tool instead called Collabora Online, which does the same thing. If I want to now, I can immediately start editing this document right within my browser, and any of the changes will be saved straight back to RSPACE. Notice now also that if I go to the bottom of the document, I can take a look at the list of any files that have been added, and here I'll see a running list of any attached files. So here we can see the MS Word file that I've attached this document earlier. Okay, so what I'm going to do now is go back to the workspace, and now I'm going to open an example basic document that has a range of more elaborate content in it that I built earlier, so that you can see the extent of the kinds of things that you can build in your RSPACE documents. So let's open this document. This document has a lot of meaningless content that I've added here in a sort of a stream of consciousness way, just to show you some of the capabilities of the text editor as quickly as I can. So naturally, you can make style text, and you can adjust the fonts and the colors and the size and the style of the text any way you want. You can add images, as we saw earlier. You can also add different file types by dragging and dropping them, or by inserting them into RSPACE. There's actually a third way to insert files. It's really convenient. If I'd like to insert any elements into RSPACE, and I'm the sort of person that works well with a keyboard, and I don't really want to use my mouse to do this, I can insert elements directly onto the page without having my hands leave the keyboard by simply typing a / like this. And that will open an insert menu for me. Then I can use the arrow keys to scroll up and down in this list. And this can then be used to go ahead and select different elements that I might want to add to this page. So for example, from here, I could say I would like to add something from my computer, or I could say I'd like to add something from the gallery, or I'd like to add a comment or an equation or a link or a sketch. I'd like to add something from Dropbox, or I'd like to add any of these other different elements here, including things like a date and timestamp if I want to, and other kinds of different things that I could choose from here. So that's a nice way to quickly generate new content without even having to muck around using the mouse or to having to use the toolbar at the top here. You can actually hit that / to get an immediate insert menu if you want to. Scrolling down, you can see I can also create tables, and I can drop any elements that I want into those tables. I can copy and paste tabular data from external sources and drop those right onto the page by using copy and paste keyboard commands. I can also generate tables of my own using RSPACE. So there are a couple of different ways I can make tables. I can either make basic tables like this to make an empty new table, or delete it if I don't like it. I can also insert calculation tables like this one here. And I can see a full list of all the different expressions that are supported by the RSPACE calculation table if I want to. Here's one that I made earlier. Let's imagine that this table is something that I use frequently. Perhaps I use this 10 or 15 or 20 times a day, and I would like to have fast access to this calculation table so that I don't have to keep rebuilding it often. What I could do is I could turn this or any other content on this page or any page into a small piece of content called a snippet. So snippets are little pieces of text or tables or images, or they can even include different files that are embedded in a document. And by creating snippets and storing them in the gallery, you can actually make your own personal library of commonly used content that you might want to work with. So let's look at an example. Let's imagine this chunk of text and this entire table here. Let's just select just the table. Let's imagine this was a complicated calculation that took me an hour to build in the RSPACE calculation tool. I could, if I want to, go ahead and say, I'd like to save that as a snippet. Let's just call this UniMiB 1 and say create. Okay, so now imagine that it's a few minutes later and I need to use the same calculation again in a different document, or maybe I need to repeat the calculation in the same document. What I can do now is I can say insert, or I could just go ahead and hit the backslash key. And then from here, I can say I would like to insert something from my gallery. And then from the gallery, I could choose the snippets area. From here, I can search for or filter for or simply look for and browse through the different snippets that I've made earlier. In this case, I'll select the UniMiB snippet that I made a moment ago. And now I'll go ahead and I'll click insert, and it's going to drop a new copy of that table in. You can see there are 2 copies of it in here now. And the one that I just inserted, I could, if I wanted to, go back to that one, and I could maybe add a new number for that to calculate some new grand totals here. And say insert. So the gallery can be used to store not just files, it can also be used to store snippets, which can be quite large chunks of content. Best of all, that content, things like blocks of text that you've written, or standard language for performing experiments, or small procedures like using a centrifuge, or working with a balance or scale. You can then take those snippets and you can also share them with your colleagues so that you can pass around meaningful pieces of content so that the whole lab will use that content the same way for consistency and for similarity of workflows between different experiments performed by different people. So snippets can be extremely useful. You can think of them almost like being your own personal multi-clipboard. In other words, there are applications for Mac and Windows that let you store information as different clips, which you can then deploy anytime you want using the clipboard feature. And RSPACE does that using snippets. Scrolling down a bit further, here's an example of a table that I also copied from another external source. This one actually came from PubChem. And then I went ahead and I added a couple of extra rows, one with an image of a molecule. And then here we have some chemical structures too as well. I could click on these to get a better look at them if I wanted to. I could go ahead and delete these if I wanted to as well. So let's actually delete both of these. And now let's say I would like to make a new chemical structure in here. RSPACE includes its own chemical sketching tool. So I could go ahead and click on the Marvin sketch tool here, which is an integration that we have. And now I could go ahead and draw whatever I want here. So, honestly, I'm not much of a chemist. So, ethane is about the only thing that I can remember from grad school. But if I were a real chemist, I would get rid of this. And instead, I most likely would already have chemical structures in different formats on my local computer. So a real chemist could look inside their local computer, find a suitable chemistry structure, like, for example, something like perhaps this. And then I could drag and drop that onto the page here to show a representation of that and say insert to then drop that onto the page. And you'll notice that RSPACE will actually provide me with a nice bit of metadata over here where I can see more information about that item too as well. So here's the thing that I just added on the page. I can save this if I want to. RSPACE is auto-saving your work as you go, so you don't have to worry about losing anything. And every time you manually save it, you're creating what's called a restore point. And restore points are shown in the revision history so that you can then go back and look at the history of a document as it evolved. I'm going to go to the home page and I'll select the document we're just working with and I'll click on revisions here. This is going to show me the full history of that document. I can actually go all the way to the last page. And here you can see that I've actually got 295 versions of this document as it's changed over time. At any time I could go back and I can view these older versions. I can restore back to an older version and I can copy this link to use inside or outside of RSPACE to point specifically just at this one particular version. I'm actually going to do that. I'm going to copy that link and I will open a text file and I'll go ahead and paste that. Oops. Oh, text editor does this to me sometimes. I'm going to go ahead instead and just say I'd like to copy link address for now. This is actually a little text editor bug on the Mac. Oh, now it's doing that thing too as well. Let me try and see if I can find a different way to do this, maybe in a different tool. You know what? I'm just going to skip that for now. We don't have time to muck around. So I'm going to go back to the workspace. So here's the document we were just working on. Here is its current unique ID. Notice that this unique ID here doesn't have any version number appended to it. This is referred to as a live link. And I can actually use this link too. So I can copy this and I can use this in different contexts inside or outside of RSPACE. So for example, I could make a new basic document and I could go ahead and paste that link into some other document. And RSPACE in this case will immediately recognize it as a specially formatted document and create a link pointing at that document. I could also go ahead and in this same page here, I could paste in the version link that I copied earlier, which I think would be this one. And you can see this link looks slightly different. The first one automatically always updates to point at the very latest version of content example. The second one always points only at version 292 of content example and will never update and will only point at that particular version. So you can choose as a user to decide how you're going to link to items. You can link to the very latest version or you can link to a specific version. When you go to the specific version, you'll see the document as it looked at that time. And when I look at info for that document, by clicking here, I'll be able to see the version number and the unique ID of the document. I will get a warning telling me this is not the most recent version. I'll be able to see any other useful information about the item. And if I want to, I can even go ahead and from here, I could click this link to go to the very latest version so I can see that too as well if I want to. Okay, so let's go back to the workspace now and look at something else. Let's assume now that maybe I would like to go ahead and explore some of the other areas of RSPACE. So you can think of RSPACE as being really several different products in one. The workspace is really the ELN part of RSPACE. This is where you create RSPACE documents that tell the story of your research and your activities so that your downstream audience can understand them. From here, I can select different items by clicking or on a mobile device just tapping on the select button. And then once I've done that, I'll have access to a range of different actions that I can perform on that item. I could duplicate it, move it to a new location. I could rename it. I could delete it. I could export it using our built-in powerful export engine. One great thing about RSPACE for academics is the entire system is built around this export engine. So you can export anything at any time. You can export individual documents, collections of documents built using a search engine. You can select all of your work very easily at any time. You can select individual files. You can select anything you want to export it in your choice of formats. All these are fairly standard formats that can be used for different sorts of things. You also even have the option to, not only can you download this data to your local computer if you want to, you can also choose to send this data directly to an external repository. And we'll talk a little bit more about this in the advanced training, but this is a great feature for letting you bundle up collections of work and sending them to locations where they can then be made available to anyone else in the world who needs access to your data. You also, as we saw, we can see the revision history of any given document at any time. I can add this to my favorites, which means a little star will appear next to it. And that makes it a little bit easier to find by going to the favorites area. I can adjust these favorites at any time. I could select an item here and say remove from favorites if I want to, and then turn off the favorites filter to go back to the main workspace. I can also share this item at any time by clicking the share button. Sharing in RSPACE is based entirely on group membership. In order to share anything, you have to belong to at least one group. If you don't belong to any groups, you won't be able to share anything with anyone. And in fact, you won't even see the share command on the action menu when you select something. So you must belong to at least one group to share something. There are perhaps circumstances where people in science do need or want to work in complete isolation and not share their work with others. But for the most part, in modern science, we usually work collaboratively. And typically, you'll want to share your work with other group members. There are different types of groups in RSPACE. We will talk more about that in the advanced training. But those different types of groups can be used to meet your different data access and collaboration needs and workflows. Typically in RSPACE, in most academic organizations, The most common type of group you'll belong to will be called the standard lab group. And a lab group is always led by a principal investigator. And the principal investigator can always see all of your work all of the time, whether you share that work with them or not. And this sort of follows standard academic models where it's assumed that a principal investigator will be managing all of the work inside a particular lab group. There are other types of lab groups in RSPACE, and some of them don't require a principal investigator and can be used for ad hoc sharing or collaboration between different users. If you'd like to learn more about the different ways that you can share and collaborate work in RSPACE, there are two great documents you should check out. First one is simply related to sharing work. So if I just say sharing here, and let's go to sharing content, and I go into full screen mode for this document, this is a good place to start to learn how to share your work. If you're interested in more advanced workflows in how to segregate data, guarantee correct ownership of data, and be able to build up elaborate collaboration schemas with different people, I would recommend that you look at this document called Examples of Sharing Scenarios. So this document walks you through a series of fairly concrete examples of how different groups may choose to organize their data and lab so that they can meet their collaborative and data access requirements. There are lots of different ways that you can do this in RSPACE. RSPACE is extremely flexible, but with flexibility comes choices, and with choices comes some degree of complexity. So if you're interested in advanced collaborative workflows, I definitely would recommend that you would read this document, Examples of Sharing Scenarios and Project Organization, to best understand how you might choose to organize your lab, organize your project work, and share work with different users in a way which is effective for your particular laboratory. If your server has been configured to do it, you can also publish your work. This means that you can make your work immediately available to anyone, anywhere else in the world. This is an optional feature that may or may not be turned on your particular server so far, and this is more of an advanced feature, so we'll talk about this in some of the other sessions. If you'd like to know more about how publishing works, you are welcome to go to our documentation and search for publish to see how the publication mechanism can make your work instantly available to other people who are not using RSPACE. If you don't see this feature or this tab, it means that this feature is not turned on your server. Notice also that once I've selected this item, I can, if I want to, send messages about this document to Slack or to MS Teams. So these are two examples of integrations that we have in RSPACE. In this case, these two integrations are designed to allow users to communicate very freely. There are actually other ways you can communicate in RSPACE too as well. You can, for example, use RSPACE's own built-in messaging system to send a message to your colleagues. And the messages that you send and receive are gathered together in a messaging tab that looks like this. The messaging tab acts a lot like an internal email system. And you've all worked with email before, so I'm not going to spend a lot of time talking about how the messaging system works. I would hope and assume that you'll be able to click these different icons and figure this out yourself over time. If we look at the Apps tab, this is where we can see and sometimes configure the integrations that RSPACE allows with different third-party tools. So you can see there is a wide range of different things that you can use with RSPACE. Some of these allow you to simply create links that point at data outside of RSPACE. Others do various more advanced sorts of things. You can also see in here we have of course, now that I'm staring right at it, I can't see. Oh, here we go. Here's the integration for Slack and Teams. And you can actually click on these here and you can configure these to work with your own particular Slack account or to work with different Slack channels that you work with. So some of these integrations allow you to perform a little bit of configuration of this to get it to work for you. These integrations are configured in two different places. The integration can be turned on or off by your server managers. If your server has not allowed you to use a particular tool, you'll see it grayed out and listed as unavailable here. This means that it's not turned on at all on your particular server. Other items, I may have access to them, but I personally have just decided not to use these. So these are disabled, and they've been disabled by me personally, but they are available to me on this server if I wanted to use them. All of these other integrations are all ones that I've chosen to use, And then in some cases, I've added some configuration to tell RSPACE about the specific account that I would like to use. Most of the time, those integrations will work through links, and we'll take a look at those next. So going back to our example document, here you can see again, we've got some text, we've got the images, we've got the tables that we looked at earlier. If I keep scrolling down, we'll see some more complex data too as well. Here's the chemical structure that I made earlier. Let's keep going. So down here, we can see a little equation that I made with our built-in LaTeX editor. Your physicists and data scientists and mathematicians will like this feature for building nicely formatted equations using LaTeX. And here we have our code snippet tool. This will allow you to drop in little pieces of code to show your downstream audience things you've been doing, like, for example, your Python calculations or your R scripts. Or in this case, this code snippet is the LaTeX code that I use to make this equation. This code is inert. It just sits on the page. It doesn't do anything. It can't be run here in RSPACE for security reasons, but you can use the RSPACE API to interact with systems that can run code. For example, things like Jupyter Notebook or RStudio, and that will allow you to send data from RSPACE to an external tool for processing, and then you can tell that tool to send the data back to RSPACE when it's done. You may also see comments on the page too as well that can be used to form the basis for a threaded discussion with your colleagues or anyone else who has access to this page. And you may see any number of links to different things outside of RSPACE. So for example, this particular link here, if I were to click it, I'll be taken to PubChem. If I wanted to, I can edit that link at any time by double-clicking the document to enter edit mode. Then I can scroll down to wherever those links are. And I could go ahead and select a link, right-click on it, and if I want to, I can go ahead and take a closer look at that link, and I can edit this if I want to, or change where it points if I feel like it. You'll also see here we have some links to other things that are in RSPACE. So there are several ways that you can generate those links. As we saw earlier, you can copy and paste the unique identifier from other locations, but there's also other ways to generate new links. I can use the internal linking tool to browse through my workspace or to search for specific sorts of things, or I can open up a navigational tree here on the left. This allows me to see my entire workspace, and from here, if I want to, I can grab particular items like maybe this, and I can then go ahead and drag and drop these onto the page to generate new links to different areas inside RSPACE. So this is a nice way to browse through your entire workspace, find things that interested you or that are related to the current experiment, and drag them on. You can leave this navigational tree open all the time if you want to, or you can collapse it to make more room for your text editor. So next I'll go ahead and scroll down a bit further, and here we can see links to things like external documents. This particular one is a simple example linking to something in my Dropbox account. When you turn on the integrations on the apps page, that will cause different icons to appear here in your integration toolbar in the main text editor. I can now put the insertion point where I want this link to go, click on the Dropbox icon in this case, choose an item from within my Dropbox account and say choose, and that will add a nicely structured link to the page. You can see here I see a Dropbox icon to tell me where this item is. You'll also notice that there is a dotted line around this file. This indicates that this file is not really in RSPACE, it's somewhere else instead. Items that have a dotted line around them actually are outside of RSPACE, and items like these files up here that have a solid line around them, these all exist physically in RSPACE, stored safely in the gallery area. So you can immediately tell whether an item is physically on your RSPACE server or whether or not what you see is a link that points at it at some other location outside of RSPACE. If your server is configured to do it, you can also link to other files that may be in university managed or nearby SMB or SFTP file servers that perhaps you have access to. We'll talk more about that in the advanced training. There are other types of links that we can make too as well. Here's an example of a link that I've generated to Omero. Omero is a microscopy image managing system that's used by many different sorts of scientists. And this link is a little bit more advanced in that it generates a slightly larger thumbnail of the image, which may be useful to a microscopist to help them see some of the detail. But it will also pull in a bunch of the associated metadata from Amero, which then makes this image highly searchable within RSPACE. You'll also notice that this link includes a link to Amero itself too as well. If I want to, I can click this to go and look at the original data inside Amero. And we can do the same thing with other systems like, for example, Pyrat and also Cluster Market. Cluster Market is an equipment booking system, and you can see here when you book something and you use the Cluster Market integration to mention that booking in your RSPACE document, you'll get a table like this that tells you something about that booking event. And then we have some chemistry structures, and that's about all I really want to show you from the text editor. Everything else, I'd recommend that you click around on the text editor yourself to practice using it just like you would if you're working with any other text editor for the first time. Okay, so next I'm going to go back to the workspace again and show you a couple other things about organization of data in the workspace. So right now we are looking at the workspace in what's called list view. I can control the number of items that I see per page. Usually I like to keep my list view quite compact with just 10 items per page. I can sort this data by clicking on these headers, which is something I can often do in RSPACE. And I can see here the unique identifier for each item. This unique identifier really is your best friend in RSPACE. Everything in RSPACE gets its own unique identifier that's unique within this RSPACE server. I like list view quite a lot because it gives me quick access to this metadata, and I can also click the info button here to get additional information about an item. And I can even see a small preview of it here if I want to. I also like list view because it's where I can select items, and then I can immediately see this action menu that allows me to quickly perform actions on the selected item. There's another way to view your workspace though. You can actually go to this area here and you can say instead, show me tree view. So tree view will depaginate your workspace and it will show you everything in your workspace. This is all the work this user has ever generated in the workspace. And this is quite an extensive list for this demonstration user. Now, actually, I'm not really mad about the way that this user has organized their data because this sort of reminds me of my old principal investigator's desktop on their Macintosh years ago that was always covered in thousands of files, and I had no idea how they could ever find anything. I would have thought a better way to do this might be to just have all of your data organized into a small number of top-level folders so that then you can expand those folders and see what's in them really easily, and you can tunnel down in the hierarchy if you want to, and from here you can click on a document to go straight to that particular document if you want to. Here I can see my location in the hierarchy. I can go up a level if I want to, or I could go back up to the top level by clicking Workspace. I can also search for items here using a standard browser search. So I could hit on my Mac, I could hit Command F and say something like liver to immediately highlight something that I'm interested in this page. Now, my own particular personal visual system is quite easily overwhelmed by long lists like this, and I have a hard time finding what I want in this list. And this is why most of the time my own personal preference is to stay in list mode, because in list mode I get this useful metadata and I can control how many items I see per page to make my work a little bit more manageable. I can also sort this work from here using different sorts of filters. As we saw, I can look at just my favorites, or I could look at just items that have been shared with me by colleagues that I'm working with, or I could choose to look at just my templates. Templates are essentially just simply pre-made workflows, and I'll show you how I make those in just a moment. Or I can also from here search for different things that are in my workspace using the main search engine. I can either do a very Google-like search where I would just search for a single term. That will get me lots and lots and lots of hits. Or I could be a little bit more specific and I could search for different categories of things. Or I could do an advanced search where I could join a number of terms together to form a true Boolean query to look for different sorts of things based on different variables. Using the RSPACE search is an important tool that all users will probably need to develop. At first, you can probably just get away with entering text terms in your main search engine and not worrying too much about the structure of your search. But over time, as data accumulates in your ELN, you'll need to develop more effective search strategies. And that's when you might start working with things like the Lucene query language, which we use a lot in our search engine. So from here, I can type in L and colon, and then I can immediately start searching for things like DNA and RNA, but not one. And that will let me form a more structured search where I'll see only certain sorts of data in the results. Okay, so next I'm going to take a look at working with a document that I'd like to turn into a template. So what is the difference between forms and templates in this list here? Well, the answer really is not much. A form is simply a list of fields that you've arranged in the RSPACE form builder, which allows you to represent a particular workflow. A template includes some additional exemplar or preliminary data to help it make it more easy for you to reproduce the workflow more precisely. So let me show you what I mean by that. If I take a look at the, let's look at when we created all of these and sort by that. And maybe we'll search by modified instead. That might be an easier way to do this. If I take a look at this document that we made earlier here, you can see here we've got some preliminary data that I've entered into these fields. When I first made this document, these fields were completely empty. If I've now got some data in here that I like, I could go ahead now and save this as a template, and I could give this a distinct name. And say, okay. Now, if I need to repeat this experiment and have a lot of these fields already pre-filled in for me, I can actually create my work from, instead of using a form, I can use a template. I can say create from template. Here I see a list of all of my templates. Here I see a list of templates that have been shared with me by other people in my lab. From the list of my templates, I'll choose the UniMiB template and say create. And that's going to make for me a new document based on this template that will already have a decent amount of data entered in it. So you can imagine that in this workflow, the first time that you perform an experiment, you might be best off using a form. But if you're performing a sequence of experiments where the only thing that's going to change between them is one variable, like this, then you're better off creating a template, since now you don't have to enter all of this data again and again and again. Most of it's already here. In general, when you're building workflows for use in your lab, we generally recommend that you always progress on to form a template, and you use that most of the time for distributing work. And the reason why is partly it has to do with the fact that the template finder tool is a little bit more advanced, and it has a search engine. It also has this ability for me to quickly see the difference between templates that I made and templates that have been shared with me by other people. Templates are also nice in that they are shared using the exact same mechanism as any other document. So once I've created a template, I'll be able to see it in my templates area. I could select it here and I can say share. Now I can choose to share that item with any group or project that I belong to. Or I could choose to share that template with different individuals within those groups and projects. And this is the exact same way that we share any other document inside RSPACE. So as I mentioned earlier, sharing is all based on group membership. If you don't belong to any groups, you won't be able to share anything with anyone. But if you belong to multiple groups, you'll be able to see them listed here, and you can decide which documents you'll be able to share with which groups. You can also share the same document multiple times. So you could share this one template with several different lab groups, and then this template will be accessible to different assemblages of scientists working perhaps in different locations or in different projects. In RSPACE, the groups that you belong to can be a flat list of non-intersecting groups across your entire server, or they could be made up of nested, concentric, hierarchic groups. This can be very good for a large lab where you want to have lots of little subgroups within a large lab organization. Or your lab groups can be quite a complex Venn diagram where you'll have many different people belonging to many different groups, and they will come and go from different groups based on their need to access different sorts of data at different times. If you're a PI and you're worried about what the group memberships might mean for your data access in the future, there's a great article for you to read to understand how long-term data storage of RSPACE works. Let's go ahead and go back to our help page again. If you're a PI interested in how your data persists inside RSPACE, you should read this article on long-term data management. It will tell you all about how your data resides in your group. And if you're a PI, it will show you how you can still access the data of people who've left your group or who are no longer using RSPACE. And also it will give you some options for things like exporting your work or archiving it, or transferring it to other users if you need to over time. There are lots of different ways that you can make sure that your access to the right data continues long into the future, even after people have left your lab or even after people have graduated and have left your organization. Okay, so now let's look at some of the other tabs here. We've looked at the workspace and the gallery where you store your files. We've looked at the messaging area where you can communicate with your colleagues. We looked at the apps tab where you can configure the different integrations you may be working with. Let's now go ahead and look at the inventory tab. So the RSPACE sample and inventory management system is a complete, sophisticated, very advanced and quite innovative sample and item tracking system that can be used for organizing any large sets of real or conceptual entities that you work with. It can be used for managing your freezers if you're in the life sciences. It can be used for managing your animal colonies. It can be used for managing paper documents. It could be used for managing electrical components or anything else or any mixture of those things that you might work with in your lab every day. It's extremely flexible. It's highly visual, and there'll be a whole separate training system later on, a training session to teach you exactly how to use the inventory system. But now all you really need to know is that it's very flexible and it can be used for storing and using anything inside your workflows. Right now we're looking at a list of things in what we call list view inside the inventory system. I'm going to look at my top level of major containers. These are things like rooms or buildings or major freezers where I keep most of my stuff. And I'm going to ask the system to show this to me initially in list view. Sorry, I'm going to change that to tree view. So when I'm looking at this in tree view, I can now tunnel down inside my container hierarchy to look for things. For example, here I can see that in this room, there are several freezers, and in those freezers, there are shelves, and on those shelves, there are freezer boxes. I can even open up the freezer box to see a list of anything that's in there. Or I could select this freezer box to load it in the details panel. Here I can see a preview of it. We always encourage users to add preview images of everything in the inventory system. And then down here, since this one is what's called a grid container, I can immediately see exactly what the location is of different samples within that freezer box. I can select the item in there if I want to and open it to take a closer look at the details. I can see this is some kind of peptide and that it's drawn from this larger sample here. When I click that link, I'll be able to see that that peptide is made up of 5 aliquots. And if I want to, I can see the current location of all of those different aliquots. I can see one of them is in this box. One of them has already been run out on a gel. Others are in freezer box 2. I could click this link here to go to freezer box 2 if I want to take a closer look at that freezer box and see exactly what's in that box. And you can see in this box, we have many samples. I can also do other things. If I go back to my top list of containers, I can define some containers as being what's called a visual container. So visual containers can be used to build sort of a map for showing you where things reside. Here's a visual representation of the room here that I'm mentioning in this particular entry. And down here, you can see I've set this up with these different hotspots on it that allow me to show the exact location of different items and what's in each cabinet. This is a great way to lay out your different rooms and storage areas so that new graduate students don't have to endlessly ask people where things are. They'll be able to find the location of all of your materials, items, equipment, samples, and specimens using this system and using these map images to quickly understand where items are located. I could select one of these and open it. I can immediately see here that there are a number of items inside this cabinet. I could click on this one. This looks to be a slide box. I can zoom in on it to see if I recognize it. And in here, you can see there are a number of different slides. And again, if I want to, I can learn more information about these by asking to see the owner or the previous location, which tells me where this used to be before it was in the slide box that it's in now. Notice also this system is highly responsive and it can be used for working with more materials on both your computer, but also on a mobile device. If you're working with a phone, you would see something like this. This particular system is designed specifically to work well with mobile devices because we logically assume that often when you are working with samples, you may be standing up and moving around within a storage area and not necessarily using your computer. So best of all, you can organize these into collections of things called baskets. I've made some baskets earlier that you can see here on this list. Here are some of the different baskets of things that I've made earlier, including things like things that I'm going to send to my colleagues at Prisma, or some liver samples here, or perhaps some taxane samples here. And you can set these baskets up to contain anything you want, groups of samples, various different containers, and you can then use these baskets for different functions in the future, as we'll see. The system includes a really powerful search engine, and it even includes the ability to work with barcodes and to search for barcodes using the camera on your phone or your computer. So for example, if I find something on my, oh, I need to get permission from Chrome here. Allow every time. So I fired up the search engine here. What the search engine is doing is it's trying to get Chrome to open the camera. Let's try this one more time. Oh, goodness, Chrome, why must you mock me this way? There we go. So that's opened up the camera on my Mac. Here I have a Petri dish in my hand that happens to have some barcodes associated with it. I mean, I could use a standard laser reader to read the barcodes off of this if I want to. That works just fine too as well. But in this case, RSPACE is looking more into the future and how this will work for every lab eventually. And I can just hold the barcode in front of the camera. RSPACE will read it. I can click search. RSPACE will say, oh yes, I know what that is. It's a Petri dish and it's supposed to be in this incubator, which by the way is in this room. So I could click on the incubator, quickly take a look at it to see if I recognize it. And if I want to, I can also take a look at the room that it's in. And sure enough, down here in the map area, I can see here's the incubator that I'm looking for, and here are some of its characteristics. So that's about as much as I'm going to say about the inventory system for now. But what I will do next here is I will now go back to one of the documents that we made earlier. And let's imagine that we now need to use a chunk of or a list of samples inside this experiment. So what I'll do is I'll go to any text editing field in this document where you can see this new list of materials button. I'll say, make a new list of materials that will represent things that I'll be using inside this experiment. I'll give this list a name. I'll call it liver samples. And for brevity, I will just use that same thing for the description. Now I can say add items. There are many ways that I can add items to this list now. I could search for them. I could search for liver here and see what I can find. Or if I want to, I could browse through the different containers. I could go to tree mode and I could rummage around inside my different containers to see if I can locate the thing that I'm looking for. Another way to do this is that if I've already set aside the things that I'd like to use in this experiment in a basket, I can look at my full list of baskets to see if I already have the things that I want to use today pre-set aside for me. So I see one here called liver. This seems like a good candidate. Let's choose that basket. And that will automatically, let's go back into list mode too. That's going to automatically populate this search engine with those. Let me try that again. Oh, I think I need to turn off that and that. There we go. And let's see if that, yeah, here we go. So this is now the basket that I'm interested in with lots of liver samples in it. There are 13 of them apparently. For now, let's go ahead and just select all of them. And now I'll say choose. And that's going to build a list of things that I think I'll be using in this experiment. Well, this box is not something I want to use. I'm going to get rid of that. Some of these have 0 quantity associated with them. They've already been used. So I'm going to eliminate those ones too as well. I don't want that one. I don't want that box. And I don't want any of these items that have 0 volume. So let's get rid of those too as well. All right, so now we're down to just a small handful of items. One of these actually is not a fluid. It's actually sections. And I can see we have 1 section available here. And I don't want to use that one either, so I'll eliminate that too. All right, so now we're down to just 3 items that we'll be using here. And I can adjust the volume that I'll be using in this experiment if I want to. I can say, first of all, I can say move all of these to my bench. And that will then allow any other users to understand that these items are not in their usual location anymore. They're currently on my specific personal bench because I'm using them in an experiment. I'm going to save this now. And if I want to now, I can say edit quantities. let's say for all of these, we are going to use just 5 microliters. That will adjust the remaining volume accordingly. And now I can say save again here. If I want to, I could export this entire list as a CSV file. I'm not going to do that today. I'll just say close here. At any time now, I can go back to that list of materials. I can take a look at it here. I could click this link to go back to the inventory system. And when I look at the info for this item and say show link documents, now here I can see a full list of every experiment that this particular sample has ever been used in. So from the ELN side, I can see a list of samples that were used in the experiment. And from the sample side, I can see a list of experiments that this sample has been used in. These are, again, good examples of the traceability features that we've built into RSPACE to allow you to understand which items have been used in which contexts and by who and when they were used and how they were used. I could also, if I wanted to, go ahead and print this entire page. That will print for me the details of that page, and then at the end of it, it will append any lists of materials that I've created. You can have as many lists of materials as you want associated with a particular document. If I go to one of my other documents, like this one, here we can see that this document has a total of 7 different lists of materials associated with it that I've added to this document. And if I want to, I can also go to the end of the document and I can ask RSPACE to show me a quick summary list of all of the different inventory items that were used in this document. And here they all are. And if I need to, I could also click one of these again to go back to the inventory system to learn more about that antibody, to be able to get any additional info about it that I want to, and to see which experiments it's been used in. We'll talk more about the inventory system and how it can do a range of different sorts of things and be used for managing elaborate custom metadata, and can also be used for generating universally accessible digital identifiers later. All right, so let's press on to something else here. How are we doing for time here? Let me check our time schedule. We have a little bit of time left. Good. So I'm now going to go back to the workspace again, and we'll now maybe look at a couple of other things. All right, so let's imagine now that we want to work through sort of a complete workflow that will help you understand how you might put all of these different things that we've looked at together. So let's go and take a look at our untitled document here. This represents the collection of some liver samples that came from a local hospital. We've got some data already entered in here, but I want to make this data more searchable to my colleagues in the future. So let's go ahead and edit the name of this document and give it a more meaningful name. Let's call it Liver UniMiB 3 and save that name. I'd also like to make this more searchable both for my immediate colleagues, but also for my downstream audience by adding tags to this item to make it clearer to my downstream audience what exactly is going on in this particular document. So I can add tags to the system from a number of different places, but from the document, the easiest way to do it is by clicking here. And this will now let me start adding tags to the system. And tags in RSPACE work sort of similar to the way you might tag images in something like Facebook, but they're substantially more advanced than that. Your server can be configured to work with tags in different sorts of ways. You could choose to work with tags that have been generated by individual users while they work, which are then automatically shared amongst their lab. Or you can choose to work with managed lists of tags that the PI or a data specialist in your lab or a data specialist at your university might build. Or you can choose to work with tags that have been imported from external sources, places like BioPortal or GenBank or other kinds of places that maintain controlled vocabulary lists of common tags. Or you can also choose to use tags that are pulled in real time from external sources like BioPortal. And this particular server has been configured to actually do any of those things. So let me show you a couple of examples here. Let's imagine I'd like to tag this to show that the tissue used in this particular experiment was liver. So I can say that the tissue equals, here I'll see a list of choices that I could choose from. Let's go ahead and say this is liver. And now I also would like to say this has something to do with non-alcoholic steatohepatitis or NASH. So I'll search for NASH here and I'll choose this tag from this list. I'm going to save these now. You'll notice that these tags here are two different colors. The light blue one, this is a tag that was built by somebody inside RSPACE that I manually basically invented and came up with in a way that suits my particular names for my lab. This tag is a public tag that was pulled in real time from BioPortal. If I click on it, I can see the text of the tag itself, but I can also see the URI of exactly what the source of that tag is and where it came from. Now, this can be fantastically useful for your library scientists because it helps you categorize work in ways that are traceable and in ways that are based on industry standards for the particular work that you're doing. The tag here, tissue equals liver, where did that come from? So this is part of a set of tags that I built manually for use in my lab. What I did was I went to create from form, and I used a special type of document that's in here called the, see if I can find it, the RSPACE tags from ontology form. So I created a document based on this form, and then I saved it into a folder that I can show you here. Here's my, it's not there, maybe the next page. Okay, here's my ontologies folder. And in here we have a number of lists of tags that I've made earlier and that I can edit at any time. Let's go ahead maybe and take a look at this one. So what I've done here is in this first block of text, I've made some tags that pertain to different sorts of transportation. These can be individual words, or they could be what's called key value pairs, where I've said the first term is car, but then I've actually added a range of different sorts of car options here. You can see one of them, for example, is Fiat. I could add something else here if I could think of a different make of car off the top of my head. What do I have that's not already in here? Oh, goodness. Let's put in something simple like Nissan as a new option for cars and say save again. If I scroll down a little bit further, here is a list of tissue types that I used to pull in that liver tissue type earlier. Down here, I've got another block of text that I use for working with algae classification. Down here, I have a list of just general words that are useful in the lab, things like lab meeting, seminar, equipment, other kinds of things that you might want to tag your data with. Now, I can edit this document at any time. I can also include other creative things like, for example, here we have a list of grade options. I can use this when I'm grading work by my students to assign grades to them as a tag. I could also assign things like color coding or chemistry types, or really anything that I want here. Other types of unique identifier that I'm already using inside the lab, like the name of strains of different bacteria or animal IDs, can all be set up to be tags if I want to. So again, in practice, how do these work? Well, if I go back to the document we were working with earlier, I can now look at that modified tag list that I made earlier. I'm going to edit this, and I'm going to say this is related to car equals, here I'll see a list of different car types, including the one I just added a moment ago, this new tag, Nissan. Let's choose that one and say save. Now, if I need to find this work later, I can go to my search engine and I can say I'd like to do a tag search, and I'm going to look for anything where the car, and you can see this will now auto complete for me and make some suggestions. This list of cars that it's offering me is not the full list that I made earlier. Why are there some that are missing? And the answer is because RSPACE is smart enough to know that only these tags have actually been used anywhere in RSPACE. So it doesn't offer you ones that have never been used. Let's choose car equals Nissan, perform the search, and we'll see that one document was tagged that way. All right, so now let's imagine that we'd like to find all of the research I had to do with liver tissue. I'm going to do a new search. I'll say, let's tag this. And we'll look for anything where the tissue equals liver, and run this search again. Here is a whole set of work now, which has been tagged in that particular manner. It's made up of many different types of document, but they all have one thing in common. They've all been tagged using that particular tag. Now let's imagine I'd like to study this cohort of data outside of RSPACE. How can I do that? Well, it's very simple. I can go ahead and just select the entire lot with one click. And now I can go ahead and say export. I'll choose to export this as a single collated PDF file. Now I'll say next. I can adjust this export if I want to. For example, I made some kind of slightly sarcastic comments in some of these I don't really want my principal investigator to see, so I'm going to turn that off, but everything else I'll leave on. And now I'll say export. In the case of PD exports like this one, RSPACE will assemble these into a fully into a complex PDF document made up of all of these joined together in a collated manner. I can go to the gallery, I can look at the export area, and here's the document that I probably just exported. I can take a look at it. Is that the one that I just made a moment ago? Let's see, creation date. No, that's actually not it. It's still building the PDF that I made earlier. So let's go back and see if it's finished. Yeah, there it is. So there's the PDF that I made earlier. I can take a closer look at it here. I can view it in high resolution in a new tab, or if I want to, I could go ahead and download it to my local computer. So now when I go ahead and I take a look at that downloaded PDF, here is everything from that massive cohort of data that I just exported. All of the documents are in here. You'll also notice that I also chose to include some provenance information in some of these. So at the end of each of these documents, in some cases, I get access to information about the different versions that were made. And you can see this is essentially a very nice way to output a block of work for examination outside of RSPACE. I could also have chosen to take that PDF and I could have chosen to send it directly to a repository, or I could have done any number of other things with it if I wanted to. Notice also that while I'm here in the gallery, if I go maybe to the image area of the gallery, there are a number of things I can do with files in the gallery too as well. I can select a particular file to again get an action menu of things I can do with this file. I could, for example, duplicate it, move it to a new location in my hierarchy. Again, I could export just this one file if I want to. We do have the capacity to perform some simple edits to images, including things like cropping and rotating the image if I want to adjust it. I can even, at this point, choose to send that file to an external file repository if my university is using one. So far, we support this system called iRods, which is a file storage system that your university may or may not be using. And we actually now have the capacity to directly send files that you've collected during your research directly to this file store for long-term storage outside of RSPACE, if that's what you want to do. You'll notice that if I go to different areas of the gallery, like if I go to the document area, I'll have different options here. I can see a small preview or a large preview. I could go ahead and open that file up in MS Office, just like I did with the document that was embedded inside a document. I can also duplicate standard documents or move these within the hierarchy. I can rename them or delete them. Notice that if I delete anything from RSPACE, it's never really actually deleted from the server. In accordance with 21 CFR 11, the rule set that RSPACE is built around, nothing is ever really deleted from the server. It stays there forever and can always be restored later. This means you will never have to worry about data being accidentally deleted or removed or becoming accessible. Anything that you create in RSPACE will be accessible there forever. You can hide it so you don't have to look at it anymore, but you can still retrieve it if you need to and access it to see the provenance or history of any particular type of data. Speaking of provenance and history, let's imagine that now you are interested in learning more about what you just did a few minutes ago in RSPACE, this document that we worked with and we tagged in a certain way. Let's imagine that a couple of days have passed and I can no longer remember exactly what this document was or what I was doing on a particular day. So another part of 21 CFR 11 compliance is that RSPACE maintains a history of every action that's been performed by everybody. Each individual user has the ability to access their own history. It's called an audit history. The principal investigator of each lab can access the history for their lab, and the system administrator can access the history for the entire server. To do that, we're going to go to the My RSPACE area. So the My RSPACE area is kind of a dashboard and a settings area where you can see certain sorts of views and you can adjust certain kinds of settings. Because I'm currently logged in as a principal investigator, one of the things I can see here is the My Lab Groups area. And if I want to, I can see a list of all the different groups and projects that I lead. I can choose one of these groups here. This is my main research lab. And from here, I can instantly see a list of all the people that are working in my lab. I can click the work folder of any of these people to see what that person is doing. Or if I want to, I could go back to my lab and I can easily from here see this is a link or shortcut to the main sharing folder that shows me all of the work that has been shared with that entire lab. And the work inside this folder is organized using a folder hierarchy that I, the PI, have designed and that I enforce on the lab to make sure that the work that's been shared with the entire lab is stored in a way that I'm familiar with and that works for me given my data organizational plans. Only the PI or special deputies that the PI appoints, who are called lab admins, can adjust the way that files in the shared area are organized. So within your own workspace, you can do whatever you want with your files, but within the shared context, the data is custom organized in a way that's defined by either the principal investigator or by data specialists assigned by the principal investigator. Also within the My RSPACE area, you can see your own profile. You can upload an image of yourself. You can register your ORCID ID. You can you can work with your settings here to control how many notifications the system will send you. And you can also see a listing of all the different groups and projects that you belong to. You can create, if your server's been set up to do it, you can create new project groups or new lab groups from here. Whether or not you can do this depends on how your server is configured, but it is possible to allow individual users or principal investigators to build their own new groups at any time. If that feature is turned off, then only your own local system administrators will be able to build new lab groups and assign principal investigators to those lab groups. There's also a directory. This will let you see the full listing of everybody that's using the server. It will let you see the labs that they belong to. And if you want to, you can visit those lab groups and get more information about who leads that lab and what's going on in that lab at any time if you want to. Over here, we have a couple of other items. Here, I can see a list of all of the deleted items that I've ever deleted, and I can restore them if I want to. Here, I can see a listing of all of the documents that I've shared with my colleagues. I can review this occasionally, and if I want to, I can choose to unshare things, or I can change the permission that I allow different people or groups to have to my work. And here we have the auditing area that I mentioned earlier. So if you're an individual, you would go ahead and just click Get Audit Report, and that will show you a full list of the history of everything you've ever done on this server. Now, this is useful for compliance and for data accuracy reasons, but it's also a fabulously useful scientific tool as well, because as human beings, we all have a tendency to dramatically overestimate our own ability to remember even really what we had for breakfast this morning, never mind which samples or which experiments we did at a particular time at a particular date. Depending on your role within the system, you may be able to add additional filters to this to look for certain sorts of things. So let's imagine that I'm a principal investigator and I see that this sample has been used here at this time, and I become very interested in this particular item from the inventory system. I'd like to know more about how it's been used over time. I'm going to copy that link, and then under the filters area, I'm going to say I only want to see the history of that one subsample. And now I'll say Get Audit Report again. Now I can see the full history of that sample dating back to when it was first created all the way back here. Here's the creation date. And then subsequently, here is everything that's ever happened to it. I can see every time it's been moved, edited, or looked at by anyone who has access to this system. If I go to the most recent page here, I can see that all of the recent activity was all performed by me. So if there's some problem with this sample, I basically have nobody to blame but myself, because it looks like I'm really the only person who's been using it. But you can do this for almost anything in RSPACE. You can search for documents, for different samples or subsamples or containers, and you can also download this audit report so you can study it outside of RSPACE if you want to. This is a fantastically useful scientific tool for helping you better understand when you perform certain experiments, which samples were used in those experiments, when and by whom, and can help you retrace your steps if you need to understand exactly what you did within RSPACE and when you did it. We also have here an export-import area. From here, if I want to, with one click, I can easily export all of my work at any time in my choice of formats. I also can do some other things here, including importing different sorts of data, if that's what I want to do. If I'm a PI, we've also made it very easy for the PI to take a look at any of the labs that they run. And you'll notice that on each lab group page, there's a single button that says Export Lab Groups Work. As a principal investigator, I can use that to, with one click, get all of my data for all of my students out of this system at any time in a format of my choice. Or I could equally easily select a format and choose to send this to a repository, configure my export, choose a destination, add some additional metadata, and send the whole lot out to a third-party repository. Currently, RSPACE supports the repositories that are shown in the Apps tab, and they include things like Dataverse and various other different sorts of repositories that we could send things to. Zenodo is another good example, but potentially RSPACE could be configured to send your data absolutely anywhere. And this brings us now to one last other point here, is that under My RSPACE, if you are a developer, all users who use RSPACE get access to the API documentation. You can make yourself your own API key at any time, and you can immediately start working with the API to build your own integrations. I really, the last 10 minutes went by very quick, and I lost track of time there. I'm going to end now so that we have a couple of minutes left over for any questions. And I did see that there were some questions going past now, so I know technically we are almost completely out of time. Hopefully people can stick around for a few minutes to review the questions. If we don't have time for that, then we're still recording this session, so actually we can record my answers and include those in the recording that would be distributed. Elena or any of the other local managers,
Yes,
are you able to maybe give me some of the most important questions that went into the chat area?
Yes, Rob, we have just 2 or 3 questions. The first
Okay.
one is by Professor Musumeci, Department of Medicine, and he writes, regarding the organization, storage and management of samples belonging to a biobank, what are the file export formats? Maybe in the appointment on the inventory module, you will be more specific. Thanks.
Yes, absolutely. We'll go into this in great depth in inventory, but the best answer to your question is that currently with your samples, we have the ability to import or export data as CSV files. And this can be exported as cohorts that you can build at any time. So I could, for example, use the search engine to search for a particular cohort of data, and then I could select everything. And then from here, I could say export. Here I get some options. I'll say I'd like to do a full export of everything, and I'm going to export it as a single CSV file. Click export. That will then export that CSV file straight to your local computer. We can also do CSV imports too as well. So it's not necessary to do lots of manual typing. Many times you can just import your samples from legacy systems using CSV files. We'll talk about that extensively in the inventory training. You're also welcome to contact me directly if you have additional questions about that.
Yeah, thank you. I have a second one by Professor Musumeci. I didn't understand whether RSPACE is an environment that can only be used online, or there is also the possibility of operating offline and then updating the work done when you return online.
Yes. So primarily RSPACE and all ELNs, in fact, are designed to be used mainly online. And the reason for that is because they are trying to make sure that they track and understand the precise history of who's done what. If you work offline, once your work has been downloaded and it's carried away somewhere, RSPACE has no ability to understand what was done to it or who did that. And so information about that interaction will be lost. So most of the time you will be connected. However, it is indeed possible to work with data in an offline mode. For example, I could take a particular document and I can choose to export it as, for example, an MS Word file. Let's say next here, and now I could choose a page size if I wanted to, and say export. That's going to export that to my exports area as an editable MS Word file. I can then get that Word file, download it, and I can edit it as much as I want offline away from RSPACE. Then when I reconnect to the server and I am reconnected to the internet again, I can actually use the create from MS Word file to choose the MS Word file that I had previously worked with and import it back into RSPACE, if necessary, overwriting the one that, that I got it from. So yes, there is at least one good option for working with data offline. Of course, the other option is anytime you're working with any data that's in an RSPACE document, there is nothing preventing you from taking the individual data files, like, again, sorry, I'll go to this example. If I needed to edit a particular file here and work on it offline, I can download any of these files anytime I want. Let's imagine I needed to work with this Excel file. I can just click download it to my local computer. I can work with that file offline without being connected to the internet. And then once again, when I'm ready to update that file that's in this page, I could do this. I can locate that specific document. I think it was this one. And now I can find the one that I've been working with offline. Take the edited version of that file, drag and drop it on top of the previous one, and it will actually replace this as a new version. When I look at the information area here, I'll see that there's some version information in here somewhere that tells me that now this is, I'm trying to see the version number in here. For whatever reason, I'm not seeing that version history, but it knows that this is a new version of that file, and RSPACE has recorded that inside the database and the provenance history of that particular document. So you can download individual files and work with them offline, or you could export the entire thing as an MS Word file and work with it offline. It certainly, though, is assumed that most of the time you'll be working in an online mode, because that's what ELNs are designed to do, and that's how they ensure the accuracy and the provenance and the proper attribution of the work to the proper users who are using the system for legal and ownership purposes in the future.
Thank you very much.
Okay, I have just one question from Biotechnology and Biosciences, Metello Innocenti. Could you please tell us if there is a maximum size for the documents that can be uploaded on and stored within RSPACE? Also, is there a standard server space for each user, or we as UniMiB have certain space on the server in which RSPACE has been installed?
I'm so glad you asked that question. It's a great question to ask. It's almost as if you were planted in the audience to ask that very important question. So I'll take the second part first. There are no data quotas for either labs or users. There is unlimited data on your server. You can store as much actual total data on the server as you want. That's not limited by either user or lab. So that's the answer to your second question. The first question is, are there limits for the maximum file size on your server? And the answer is yes. Each server has its own configured maximum file size, and that can pretty much be anything you want. By default, on most servers, it starts out as being 30 megabytes, but your managers could choose to increase that. And by the way, UniMiB managers, if you're not sure how to do that, I can actually show you how to change the file size on your server at any time. And that can be increased or decreased. Your managers might choose to decrease it if they want you to store most of your larger files on, say, for example, a university managed iROD system, and then link to it from within RSPACE. Or if you don't really have a lot of other university file stores, you may choose to increase that size limit. Usually the maximum that although really there's no theoretical limit to how big that maximum file size should be, in practice, we recommend that you would not use RSPACE for storing files larger than about 2 gigabytes. And the reason for that is because anything bigger than that, and you're starting to get into the realm of file sizes that can't be reliably transferred across the internet without the connection being interrupted at some point, damaging the file. So theoretically, you could set that limit to anything you want, but a good best practice generally is not to set the maximum file size in RSPACE larger than 2 gigabytes. For files that are larger than that, you should probably be keeping them in a more efficient external file store and then linking to them from within RSPACE. I hope that answers your question.
Okay, so I don't see any other question at the moment. So thank you for your attention, and thank you, Rob, for the training session. Lots of information. So feel free to email us for any other question, even in next days. And the appointment is next Monday at 2 p.m. with the advanced user training. So
I will add one last point too as well. I always think of the training as being not just what I did, because I understand that this is an enormous amount of information and that it exceeds the attention span of most normal human beings to grasp that much information being fed to you that quickly. And that's why I always say that the real training is a combination of what I just did, plus on your own time going through the video a few moments at a time and pausing the video, and then really copying what you've seen me done with your own RSPACE account, so that you start to have what we call muscle memory, a better idea of where the different icons are located. You will not remember most of what I just said unless you rewatch the video and practice doing it yourself by copying some of the things that you saw me do. And I always think that that's really a very important second part of the training. So do watch for the link for the recorded session, and please do take the time to go through that and try to copy some of the things that you've seen me do on your own RSPACE account.
Yes, we are going to deliver this this recording so that they can go on with the second part of training. Yeah, thank you, Rob. So that's all. If you want, we can close this session and have our next appointment on next week.
It's been a real pleasure working with you guys, and I'm looking forward to talking to you again soon.
Yeah, thank you to you. Thank you to everyone.
Bye.
Thank you very much.
Bye. Bye-bye.
Bye.
Thank you very much. Bye.
Bye.
Thank you. Bye.